Dr. Shalini Hanok, Assistant Professor in Electronics and Communication Department, ATME College of Engineering, Mysore. Today I will be doing an experiment in communication lab, that is amplitude modulation and demodulation. Let me explain the theory about it. Amplitude modulation is a modulation technique which is used in electronics and communication. It is most commonly used for transmitting message with a radio wave. In AM, the amplitude or the strength of the signal of wave is varied in proportion to that of message signal, that is audio signal. This is a waveform. Here we are having a message signal, low frequency message signal, then we are having a carrier signal. Finally, we are getting the modulated signal. So there are three things we can see, three modulation indexes we can see in the modulated signal. So in the modulated signal, we are going to measure the maximum amplitude and the minimum amplitude. Finally, we are going to calculate the modulation index, which is given by Amax minus Amin divided by Amax plus Amin. This is under modulated wave which we will be getting, that is 50% modulation index. Here we have perfectly modulated signal, that is 100% modulated signal. Amin we are getting 0, Amax we are getting some voltage. Finally we will be getting 100% modulated signal. This is over modulated signal, wherein there is an overlap of signal which is happening here, and also a phase reversal which is happening here, and this is over modulated, so we are getting 150% modulation index. This is the waveform for demodulated signal, that is we are recovering back the message signal. This is how we will be getting. This is the circuit diagram for the amplitude modulator which we are doing in the lab. We have a transistor which is connected to the tank circuit. Inductor and the capacitor together is forming a tank circuit here, and we have resistors used here for biasing purpose, and we have carrier signal given here, and we have a message signal. Here we are using a capacitor. Finally, we'll be getting the amplitude modulated signal at this end. These two capacitors are the coupling capacitors which we are using, and this is the tank circuit which is mainly used to get the modulated signal, which will filter out all the harmonic frequencies which are present at the input, and acts as a mixer, which finally what we are getting here will be the amplitude modulated signal of Fc plus Fm and Fc minus Fm signal, filtering out all the harmonic frequencies. This is a circuit for demodulator which we are using. We have a diode, resistor and a capacitor. This entire circuit acts as an envelope detector which detects the message signal back and gives us the demodulated output. Now let us see the experiment done in the lab. The components here we are using SL100 transistor and two capacitors and the resistors. This is the carrier wave frequency which we are giving. This is the M of t, that is message signal from the signal generator we are giving, and this is the circuit. We have rigged up the circuit here, and the modulated signal which we are getting is like this. This is under-modulated signal which we are getting, that is 50% modulation index. If we vary the message signal here, we will be getting perfectly modulated signal at one point, where A minimum is 0. This is perfectly modulated signal. If we still vary the message signal, we will be getting over modulated signal. So this is this is perfectly modulated signal. This is the under modulated signal. Now we will see how demodulation we are getting. So we are using a diode for detecting the envelope. Okay, it's here. Okay, see here. We are getting the message back. It's more demodulated. The envelope is detected and we are getting a perfectly demodulated signal. This is about amplitude, modulation and demodulation experiment in communication lab. Thank you one and all.